All right, we're gonna simplify and summarize those properties. When we multiply two things with the same base like we did up here, that's called the product of powers. So product of powers and I'm going to show it to you with numbers, and then I'm going to show it to you with letters, because we're still trying to get in the habit of using letters for numbers to get ready for algebra. So let's use 4 to the 7th power times 4 to the 2nd power. And we're multiplying those together. So what we just did, we know we can add our powers. So if the product of powers means if I'm multiplying two things that have the same base but are raised to powers, I can just add those bases. All right, and now with letters, this is the way you're going to see it if you Google product of powers rule. It'll be A to the m power times A to the n power equals A to the power of m plus n. All right. Actually, I'll change these to stars so they're not as easy to mix up. All right, now the next one we talked about, this one is a power raised to the power. So we'll call that the power of a power. And I'm going to keep using 4 as my base, because that's a nice number. 4 to the 3rd power, all of this to the 5th power is equal to, well, what did we do before? We said that turns into multiplying. So I'm going to do this. This is going to turn out to be 4 to the 3 times 5. And if you Google it, you're going to get letters, so I'll show you that too. A to the power of m raised to n is equal to A to the power of m n. All right. Now let's talk about something else. We talked about the power of a fraction, but I'm going to talk about a power of a product. So up here what we did was we had two powers and we were multiplying them. What we're going to do down here is I'm going to have 4 times 5 all raised to the 6th power. And now how would I do that? Well, I'm going to have, this is the same idea as we were doing before. 4 times 5, 4 times 5, and we can write this 6 times over. To kind of see what we're dealing with. 1, 2, 3, 4, 5, 6. All right, and these are all being multiplied together. That's what means when parentheses are next to each other. So this is all multiplication, and the special thing about multiplication is I can do it in any order. So if I wanted to switch this, for example, I could switch that 4 and that 5 and I ended up with 4 times 4 times 5 times 5. And the rest of this would be the same. Or what I could do is I could notice that, hey, if I'm multiplying 4 times 5 by itself 6 times over, I can just solve what's 4 times 5. 4 times 5 is 20. All right, now I'm multiplying that by the same thing over and over. Each one of these is going to become 20, and then I have 20 times 20 times 20, blah, 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 blah. And how many 20s do we now have? 1, 2, 3, 4, 5, 6. Oh, look, it's the same number of 20s as we had 4 times 5s. And so this is equal to that 4 times 5, whatever that was. You can solve that and then just put that raised to the power. If I ask you to write something as a single power, this is the answer I want. Do not go in and Google 20 to the 6th power. I don't want that number. I don't care about that number. This is what I want. The other way this could have worked out is we could have split this up into, okay, I see 1, 2, 3, 4, 5, 6 4s, and I can group those all together times 1, 2, 3, 4, 5, 6 5s. Oops, so used to writing 4s. 5 times 5 times 5. Blah, blah, blah. I need to pick smaller numbers for powers. And then this is the same as 4 to the 6th power times 5 to the 6th power. If I ask you to write it as a single power, this is what I want. If I ask about the product of 2 powers, this could be what I'm looking for. You need to pay attention to what the questions are asking. All right. What would this look like with letters? Well, we could have A times B as our base, usually. And we're raising all of that to the letter M. And we can rewrite that. Rewriting it like this wouldn't make sense since I don't know what A times B is. But I can write it like this, and I can break it up and say that's A to the power of M times B to the power of M. And it's just the same thing. All right, and now back to when we did already discuss quotient of powers. If you remember what quotient means, you get a gold star. Quotient is the fancy math word for division. So I have 4 on the top and the bottom. This is what kicks in when I have the same thing on the top and the bottom. If this was a 5, this would not work. But when I have 7 on top, 5 on the bottom, what did we do before? Well, we wrote out 4 7 times on the top, 4 5 times on the bottom, and then we canceled out. And we do 4 to the power of 7, which is our number on top, minus 5, the number on the bottom. And I'm more interested in you knowing the math because you guys can do 7 minus 5. I really hope you can do 7 minus 5. I'm confident you can do 7 minus 5. All right, now let's write it with letters. a to the power of m over a to the power of n is equal to a to the power of m minus n. All right. There's a couple more quick properties that I want to go over with you guys. And if you Google properties of powers, properties of integer powers, or integer exponents, you can find a list of all of these. I'm trying to talk you through it, but if you've already got it, feel free to go on and do your practice and put in your answers and get full credit. But we've got three more. We're going to talk about, I'm going to save that for last. Because I did cover it. Actually, I covered it already. So negative powers. Or we'll say more specifically negative exponents. If I have 1 over 4 to the, actually this could go both ways. So I've got 4 to the negative 3. I have to flip this from 4 over 1 to 1 over 4 to the third power. If I started out with something on the bottom with a negative exponent, I'm still going to flip it, but now it flips up to be on top. Whichever side it starts on is negative, it has to go to the other side to get to be positive. And we do not write our answers with negative exponents unless I explicitly ask you to. So this will be 1 on the bottom and 4 to the 6th power on top. And we'll write that with letters. A to the negative m is equal to 1 over a to the negative m. All right. Now, zero exponent. Four to the 0 power is what? If you said 1, you win. If I ask you what is anything to the 0 power, it is 1. A to the power of 0 is 1. Now, 4 to the power of 1 is 4. I can't raise anything to a power and get 0. Except 0. Yes, I know. All right. Now, the power of a quotient. What if I have 3 over 4 to the power of 5? Well, what can I do with this? I could just do 3/4 times itself 5 times. But if I want you to write things as quotient of powers or the product of powers, this is not going to cut it. And if you try to plug this into a calculator or plug this into Google, it's going to spit out some gross decimal that I do not care about. What I want is I want to see this 3/4. Well, I know that the exponent means I'm multiplying it 5 times. And I know that if I'm multiplying fractions, I'm just going to multiply across. So another way to write all of these fractions multiplied together is on the top I would have 1, 2, 3, 4. I'd have 3 multiplied by itself 5 times. And on the bottom, I've got 4 multiplied by itself how many times? 5. So another way I can write what this is on the top is 3 to the 5th power over 4 to the 5th power. And that's how we're going to break this up to get the power of a quotient. 3 to the 5th power over 4 to the 5th power. And with letters, that comes out as A over B, all raised to the power of M, is equal to A to the power of M over B to the power of M. All right, and now if any of these are really confusing to you, if you're really stuck, one thing you can do is you can look up these power names and look for videos on specifically those powers. Look for other videos on YouTube or something that will help, okay? You can also reach out to me during my office hours if you need any more help. Good luck.